Hello, in this video you will learn how to use MessagePack and also why to use it. Essentially what it does, it serializes some structure, right, an object in C# into a file, a binary file. So you don't have to use JSON format, you don't have to use XML, it's just pure binary format, which obviously, it's better for things like binary attachments in your arrangements. The object will usually be some kind of a class, probably containing some lists and things, and maybe some binary arrangements. And if you do that in JSON, you have to do base64 strings. It's not very efficient. And as you actually see in the code, once we get to it, we have a little benchmark going here. It will be quite a bit more efficient with some details added as well. So let's take a look at the code. It's quite straightforward. The first thing you need is adding NuGet package MessagePack. So that's the only thing you need, nothing in addition to that. And now let's go to program.cs. It's a basic sort of arrangement, and let's take a look at the code. Before the program.cs, let's take a quick look at the model here. That's essentially the object that we are serializing into that binary file. A binary file, you'll have obviously, you'll have to read it in the same way you wrote it, so we have to use somewhat of the same versions at least. That's why we have this library, so it's not something generic. We don't have to follow perhaps a certain format that's it will keep going for as long as it's supported, but something to remember, of course, compared to JSON, because JSON structure, it is sort of a structure that's not going away. This, however, you have to use this library and you have to use this a certain way of doing it. There is a bit of a description here how the actual algorithm as such works. So we do need to add whatever object we are serializing. This will essentially be the definition of a file. So the notebook file will be .bin something, whatever you want to call the format, nbin, we'll call it here. And then you need to set it with an attribute as MessagePackObject. That's it. You don't need any sort of additional things or anything like that. But anything that's another class as a property, as a list perhaps, or as a standalone property, not a list, you also need to add a MessagePack attribute. So anything you have there. And then the keys, that's how the serializing works. So your whichever property you have, it's going to be 1, 3, 2. It doesn't necessarily matter how you arrange it, but you do need to add those keys like that. We can actually look at this last one in the node list. This is what I have mentioned before. The attachment is a really nice thing because we get rid of that base64 dependency, that massive, perhaps thousands of characters string, which becomes extremely inefficient in JSON or XML. We are only comparing to XML in this case, but you will see with, or rather with JSON, but with XML it would be basically the same case. So again, you just put your keys in. You can get this code and you can read these comments and play around with key arrangements. It's available on Patreon as well as some other free stuff for our subscribers. It's all there. You can download and play around with it, but there's not much to do. MessagePack object attribute, and then the key on every property you actually want to write into that file based on that class. And of course, version control is important. You can't really change names, and you want to be careful of those things as well. Now, let's get to the program.cs. Very straightforward thing. We just put in 5,000 entries as nodes. A little dev journal, whatever, a little example, doesn't matter what it is. We do a very tiny attachment. In this case, we could make it a lot larger, and realistically, if it was an image or something of that nature, PDF file perhaps, it would be quite a bit larger. And then we do 5,000 of those, and then we serialize that massive object into a file. So This is quite a lot of code, but really it's all just noise. Let's zoom in a bit more. Start stopwatch. That is just to check the performance, nothing else. Um, we could actually be restarting here. It would be sort of a bit perhaps better, but really makes no difference. This is sort of meaningless. But the actual thing, how you use it, you just use MessagePack serializer. No constructing any classes, no interfaces, no sort of fancy setup needed. You just take it as a method and you pass through your constructed object to that method, and it gives you bytes. And the bytes is that new file. Now, this will be just a simple binary, which we'll run it in a second and you'll see results. It's actually a bit better than just simple JSON. However, it takes a bit more time than simple JSON. It takes up less space, but a bit more time. We'll take a look at that. Now, if you want to make it really efficient, you need to use a bit of compression. Now, compression, interestingly enough, compared to JSON and compared to this basic arrangement, just using serializer without options, it actually takes less time to complete, and it's also a smaller file. So quite interesting, because usually when you're doing compression on files, the more you compress it, the more time it takes to do it, at least in general. But we don't have too many options. We use MessagePack serializer option standard. There's only standard here. There's nothing additional. And then with compression, we have LZ4 block or block array. Always use block array, it's more efficient. So we essentially, it compresses into block arrays, does its magic with LZ4 algorithm, and it becomes a bit more efficient. And other than that, you then pass your object and then your options. Now, again, as far as the options go, we can take a look here, not the bytes, but the options. There's really not much to choose from. There are some things like sequencing pools, and then you can play around with assembly version mismatches. So if you have difference of version of MessagePack, you might sort of avoid those conflicts, but it's a bit of a tricky thing, so better sort of to keep compression and decompression as such in the same version if possible. Just something to mention, because with these binary arrangements that does happen, and even though you have the same structure, versions might change, something new comes out, and it will look as a broken file, but really it's just a version problem. So serialize, object, options. There's not many options to choose from, and that's it. The other example here, we're just serializing a JSON file, creating a JSON file for comparing it. Now, the last thing to look at before we take a look at the performance and just kind of run it and talk about it then, we have Deserialize. Again, same exact, very easy thing. So MessagePack serializer is not some different class like Deserializer. It's all straightforward. Two methods essentially, serialize and deserialize, and you need to specify to which type you're actually deserializing to, and that will be your object. And of course, you need to open a file reader, essentially a byte reader in this case. These days it's very easy to do in latest .NET 10, C#, so not much to it here. You just open a file reader and read all bytes, and then the serializer will take care of it. Again, no setup, really just get those bytes from the file, start reading that file stream, and that's it. You get your object. And we have a bit of output here in the hex dump. Again, that's a bit of noise, so we can actually look at the performance. And now let's run it and take a look. We have 5,000 records. It takes a second to run. And in fact, it takes quite a bit less than a second to run. So as you can see, with 5,000 nodes, the results are clear, and if you raise the number or if you lower the number, it will be the same sort of a pattern. With JSON, we get 1.5 million bytes, so quite a bit larger thing than n-binary. This is without the compression, this one. It's still saving space, however, it is a bit slower. So if you value speed, then JSON perhaps is better. But again, once you start messing with that base 64 as a larger one, probably all in all, it's not going to be that speedy, because you'll need to do that conversion and it's going to be even worse. Here you kind of don't have to do that. You just provide the byte array and that's it. So you could do it from a stream directly, and that would be a sort of separate test, but that would save even more time on the whole thing, and probably quite a lot more space as well. But there's no reason not to use the LZ4 compression. It doesn't damage anything, it's still healthy. There's really sort of no downside to it, and as you can see, the file itself is just tiny compared to all the other options, 10 times smaller, and more importantly, it's a lot faster as well, which is an interesting thing when you're using compression. Watch some of the other videos on this channel. We have a video on just compressing files using C# zip formats, not just zip, but RAR formats and all these other different formats. So not just the basic kind of thing. There's a special library for it, but you'll see the more you compress, usually the slower it becomes as well. So something to keep in mind here. But the setup is simple, and again, especially if you don't need it to be human readable, human editable, if you do need that, that's not the format for you. You can sort of also save the gRPC payloads like this. There is that use case, but really if you have to save something that will require to be opened with your same application, and it contains maybe images, maybe short videos or something of that nature, maybe PDF file extractions, definitely a good way to do it. Of course, these files can still get large, so do be careful about it, and perhaps split them up a bit, or save raw files and just do the references for them. So there's lots of techniques to actually do it. But the source code is available on Patreon. Take a look at that. There's some free courses for certain subscription tiers. And that said, we will conclude this video.